AI doesn't need data centers anymore. It can live on a chip inside an embedded system running silently in your car, on a factory machine, or inside the smart energy meters. That is the Edge AI technology. Intelligence developed right at the source of the data, and it is changing how embedded devices sense, learn, and act instantly with no dependency on the cloud. But how does it work? If you are new to the Edge AI and want to know what is it and how does it differ from traditional AI of cloud computing and cloud AI, check out our last video in which we have deep dive into it and understand how to run AI algorithms, AI models on a MC or MPU. Now, in this video, we are gonna go to the one step further. We are gonna go and went to the 5 powerful Edge AI use cases on how they are transforming the embedded system devices and the products across the industry. Specifically, we are going to focus onto the energy industry through the smart energy meters as an example to understand the Edge AI use cases. Now, let's begin with one of the most widely adopted Edge AI functionality, analogy detection. Analogy detection is the ability of a system to recognize a set of patterns, data patterns, or behaviors that deviate from what is considered as normal operation. Let's bring this analogy detection to the real world example. A smart energy meter. Let's say it is installed in a retail store, and over the time, this meter learns the typical electrical behavior of that retail store. That voltage is around 230 volt. Current fluctuates between 2 to 5 ampere during peak hours, and the energy usage is maximum at the time of morning and evening and drops late at the night as per the occupancy of the retail store. And this consistent behavior forms what we call as a normal operating profile. Traditionally, meters rely on rigid thresholds. That is, if voltage is greater than 250 volt, raise the alert. If current is less than 1 ampere for 10 minutes or more than 10 minutes, log the event. But now imagine this. It's a busy weekday afternoon and the store is open, lights are on, and appliances are running. Typically, around this time, current draw is around the 4.2 to 4.5 amperes, and energy usage climbs step by step as hourly basis. But today, something is different. The current drops to just 3.1 amperes, not low enough of 1 ampere to trigger any alert, and the energy consumption graph flattens even though the store is hustling with the crowd. No alarms go off, and yet for a system that knows the usual pattern, this is unusual. To a traditional system, everything will appears to be within a range. But to a pattern-aware Edge AI model that is deployed in energy meter, this deviation is quite a signal pointing to something deeper. It knows that this behavior doesn't align with the past weekday patterns and the busy schedules. It detects the correlation between voltage, current, and energy is breaking, and that it reflects the event as an analogy, possibly pointing to a failing load, loose wires, or even an energy theft. And that is the power of Edge AI based analogy detection. Not reactive, not rule based, but adaptive, real time, and intelligent right at the device level. Next use case is of pattern recognition. Pattern recognition means teaching a system to recognize recurring behaviors or usage signatures and understand what they mean. Take out smart energy meter again. Throughout the day, it captures patterns on how electricity is consumed. Maybe there is a surge every morning at the coffee machine and the water heater kicks in. Midday loads drop when the people are out at work. And in the evening, the pattern shifts again as TVs, lights, and kitchen appliances come out light again. These recurring usage shapes the AI model. When usage happens, how long usage happens, and how usage evolves from energy consumption patterns of the load. Traditionally, existing energy meters couldn't understand these patterns. They could log the data, calculate the average or totals, but they don't know what a weekday evening pattern look like versus what the weekend ideal states. And now imagine this, it's a weekday afternoon. Normally, energy usage is low, but suddenly there is an unfamiliar pattern draw that doesn't match the usual load patterns. And this waveform is distorted, and the timing is odd. A traditional smart energy meter couldn't notice this and anything wrong. But an Edge AI pattern recognition energy meter know that there is some unknown device with irregular characteristics that has just come online. And it doesn't stop here only. The system starts to correlate this with the previous data. Has this happened before? Does it coincide with the voltage dips of the existing loads? Or is this load affecting the power quality? This level of pattern recognition allows the energy meter to detect behavioral shifts, monitor operational integrity, and provide actionable insights at the real time. And pattern recognition don't just make the meter smart, it makes the situationally aware. It knows what to expect when expectations break, and it knows when to raise the flag. Now let's talk about the third important use case, source identification. What is source identification in Edge AI? It's the art of not just knowing that something is wrong in an embedded system, but knowing where the problem is exactly coming from. Consider it's at 11 a.m. on a regular weekday at a working space work nest. A busy co-working space filled with startups, freelancers, creative teams, and there are a number of electronic gadgets and devices being used, like laptop chargers, HVAC systems maintain the temperature, mix of 3D printers, coffee machines, and shared servers are being pulling the power continuously throughout the facility. And then, without warning, the same energy meter picks up a certain spike in harmonic distortion. And this isn't just noise. The harmonics can cause the overheating, degrade the power quality, or disrupt the sensitive electronic devices. In a traditional system, you will get a systematic generic alert, harmonic distortion detected. But that is not where the problem ends. The story begins when you don't know that which new device is plugged in because of which this has come up. Is it a faculty power supply in the server bay or an overloading copier machine kicking in under stress? You would left to be guessed with manual checks begin. Devices plugged, unplugged, work gets interrupted, and a lot more manual work. But with source identification, FGA based models running inside an energy meter, the smart energy meter doesn't just raise an alert on harmonics being on harmonic distortion. It identifies the source. Normal harmonics are originating from the 3D printer in the prototyping way. This response is instant right from the edge device without any delay or need from a cloud analysis. And that is the value of real-time source identification. Maintenance team knows exactly where the problem is coming from. Troubleshooting is fast and accurate and focused, and the system turns from passive monitoring to the active diagnostic. With source identification, Edge AI transforms reactive monitoring to proactive troubleshooting, making the energy meters a central part of system intelligence. And now comes the fourth Edge AI use case, time forecasting. Time series forecasting means using past trends and patterns to predict what is likely to happen next. Consider our energy meter not only knows how much power is being used, but it predicts what will happen next. Sounds great? Know why? Because energy meter consumption is cyclic and seasonal. Usage changes based upon time of day of week, or the weather. And if the meter can forecast that how much load will it be drawn in the next hour, what will be the voltage drop during the peak time, or when the energy demand is likely to surge, then power distribution by the grid systems can be done accordingly. Traditionally, such forecasting was done using cloud-based platforms that process large volumes of historical energy data. But this approach comes with critical trade-offs, including high infrastructure costs of the cloud, serious data privacy concerns, and continuously streaming sensitive energy usage patterns of a user to the cloud opens up vulnerabilities for the cyber attacks, unauthorized access, which can compromise the privacy and the national infrastructure grid and power grid security. With Edge AI, the energy meters becomes a local forecaster. It can learn from historical data and behavior of weeks or the months that at 12:15 a.m. in midnight AC will spike by around 2.7 kilowatt, and the solar battery should pre-charge at 11:30 a.m. for the maximum solar, and the voltage at the phase B might dip if the kitchen loads slightly. This is specifically important for microgrid technologies where Edge AI models help in balance electrical generation, electrical storage, and the electrical consumption right at the edge without any cloud dependency. In a world moving towards distributed dynamic energy systems, time series forecasting based Edge AI on the energy systems of the smart energy meter brings the intelligence right at the edge and act instantly. And now let's brainstorm the last Edge AI use case, predictive maintenance. First of all, what is predictive maintenance? Now, what if your energy meter could tell you when a connected appliance is about to fail? Imagine this, the meter notices that the refrigerator in your kitchen is drawing current slightly slower, slightly over the past peak. The voltage drop during the startup is getting steeper. These are small but unusual harmonic distortions. To a human or to us, it's just a noise or just usual readings. But to an Edge AI model trained on equipment behavior, this is a pattern of gradual degradation, a classic recipe to failure. Traditionally, maintenance was reactive. Something broke, you fixed it. Then comes the scheduled maintenance, servicing devices at the fixed intervals and regardless of the condition. But now with the HCA, we can achieve the condition based maintenance using the predictive maintenance based HCA models right at the energy meters. And by this, the system can estimate how soon a device is about to fail by closely monitoring its voltage and current values, which component is degrading, and whether the immediate action is needed or it can wait. This means fewer surprises breakdown, reduce downtime, and optimize service costs, specifically in high-paying infrastructures of industrial machines or the building management systems. Your energy meter becomes more than just a billing device, it's a predictive, sentimental guarding your appliances. And that is how Edge AI is transforming the humble energy meter into an intelligent system capable of learning, predicting and acting in real time, right where data is generated. From detecting analogies and recognizing usage patterns to pinpointing the root cause of issues, forecasting energy demand, and even predicting the equipment failures. Edge AI is reshaping how we manage power, reliability, and maintenance across industrial, commercial, or residential infrastructures. And at Gettobyte Technologies, we are helping companies embed this intelligence directly into their products using NXP powerful Edge AI platforms, microcontrollers, and microprocessors. So, if you are building your smart energy solution, industrial devices, or power management product and want to add AI at the edge, reach out to us at Get2Byte Technologies. We would love to collaborate and help you bring your intelligence to your embedded systems. And before that, stay tuned for our next video in which we are gonna decode Edge AI use cases in battery management systems (BMS), unlocking smarter energy storage, balancing, and safety mechanisms. Until then, keep innovating, keep building, and drive the intelligence live at the edge. Subscribe to our channel and share this video to the maximum people so that more and more people can be aware about this Edge AI technologies. Till then, be skilled engineer and not just graduated one.